All right, well, first I want to welcome you to the Maryland Center for Entrepreneurship, which is part of the Howard County Economic Development Authority, and 3D Maryland, which is an initiative of the Maryland Center for Entrepreneurship. And 3D Maryland is in conjunction with the Regional Manufacturing Institute of Maryland, and you'll hear a little bit more about that today as we go on. About a year or so ago, Howard County Executive Ken Allman challenged the HCEDA and the MCE to come up with some new innovative models of economic development, and 3D Maryland is one of the answers to those challenges. And it's a way of, we're setting out to drive innovative economic development, identify needs, and fill gaps as a way of growing business in Howard County and in Maryland. So that's our mission. 3D Maryland is, I actually want to thank our sponsors today, Nextline Manufacturing, Greg Paulson and Chris Flory. If you guys would put your hands up. I see Greg, I don't see Chris.
You may be in traffic.
It was a little tough this morning. And Dr. Michael Galeazzo, the president of the Regional Manufacturing Institute of Maryland. So just a little bit about Nextline. Nextline Manufacturing is a service bureau located in Gaithersburg, Maryland, providing both additive and subtractive manufacturing services across multiple manufacturing processes. And I want to thank Greg and Chris for being here today and being supportive of 3D Maryland. And the Regional Manufacturing Institute of Maryland for over 20 years has been advocating for manufacturers and for building manufacturing in Maryland. All of us who know Mike know him as a creative and tireless force for manufacturing in Maryland, and we're fortunate to have him. So for those of you who don't know me, I'm Jan Baum. I'm the Executive Director of 3D Maryland, and along with Dr. Michael Galeazzo, we're happy to host today's forum for manufacturers on information around 3D printing and additive manufacturing. And the goal for today is to give you guys more information about those technologies and how these technologies can positively impact your business model. I get asked a lot about 3D Maryland and what 3D Maryland is or what it isn't, and so I'll just give you a little bit of an intro, but I don't want to take too much time on that. So 3D Maryland really is leading the charge around 3D printing and additive manufacturing in Maryland, and we're at the right place at the right time in creating 3D Maryland. The response to our initiative so far has been absolutely tremendous. We're at our 6-month milestone, and we're just getting started. Helping Howard County and Maryland increase competitiveness, increase the bottom line, and increase job growth. You're going to hear from some industry folks today about how they have used these technologies to increase their competitiveness and their bottom line. 3D printing and additive manufacturing, one of the things about these technologies that makes me really excited is with the application across industries. And building on the region's strengths and core competencies and the tremendous resources in the state, we have a very real opportunity to grow Maryland into a hub for 3D printing and additive manufacturing, increasing Maryland's competitiveness. And the time to do that is now. And as you'll see as we go through and as you learn more about 3D Maryland, Maryland is very engaged in the rapid tech ecosystem. In Maryland is very, very strong. When I'm out there talking to people about what we're doing in Maryland, frequently the response is, I don't think any other state is doing this. Or last week I was with the White House Office of Science and Technology Policy, and they suggested that what 3D Maryland is doing should be the blueprint for other states across the country, and I thought that was a really interesting response. And indeed, we are attracting attention and resources from outside the state, and I can talk about that more with you one-on-one if you're interested. So 3D Maryland is marshaling resources, building a loosely coupled system of collaborative relationships and partnerships across sectors, and working to break down silos. We have an interactive online map that's on our website, www.3dmaryland.org, and we currently have over 85 flags on that ecosystem map, and those are the service providers. Those are the business and industries using the technology, our federal labs, and our educational institutions as well. We have a professional users group, so those of you already many of these folks are part of the professional user group. We have had over 250 people attend one of our monthly events in the last 6 months. So when I say Maryland is engaged, we have a really strong rapid tech ecosystem, there's the proof on that. And we're connecting assets in the state to help business and industry be more competitive. So there's a lot of resources here, but we're working to connect those and to create that loosely coupled system of relationships. We are seeking university-level interns, and not just from maybe computer science or from mechanical engineering, but from economics and from entrepreneurship. So we would love a host of interns in 3D Maryland, in the Innovation and Prototyping Lab, from across the state, so that we can nurture the talent pipeline, which is huge, and you might hear a little bit about that today, but also bringing more people into the facilities and the resource that is 3D Maryland. For the last 2 years, RMI, the Regional Manufacturing Institute of Maryland, opened the doors to Annapolis lawmakers, where we have co-hosted the New Image of Manufacturing Day. And I know if you go on the RMI website, you can see some really nice images of that event, at least this year, if not last year. And this year what we did is we took a lot of folks from industry and business that are using these technologies, and we created a showcase for lawmakers as a way of educating them about these technologies and the competitiveness of them. So we've been really busy. There's a lot of success stories. If you guys have been at our open house or our press conference launch, or if you've been at any of our other events, you've heard little anecdotes. I'm not going to share many more today, but like I said, there's a lot of information on our website, www.3dmaryland.org. Please go and take a look there. We are in the planning stages of putting together a cohort program for manufacturers as a way of demystifying the technology for you, helping you find on-ramps. So if you're interested in that, please see me and I can follow up with you about that. Metrics are also very important to 3D Maryland. So if you, as you engage going forward today with the ecosystem, and 3D Maryland's been helpful, let me know about that so we can trumpet that and we can continue to feed that. And then the last thing, probably most importantly, maybe one of the most important things I'm going to ask of you today, is on our website we have a survey about how 3D Maryland can help you. So it's about a 2-minute survey. It's literally 8 questions. If you wouldn't mind going on and taking our survey, I'd really appreciate that. At this time I want to invite Dr. Michael Galeazzo from the Regional Manufacturing Institute of Maryland to say a few words about our program today.
Can I do it from here? Okay, well, good morning, everybody.
Good morning.
Good morning. This is an exciting time because I was kind of reminiscing about 3 years ago when I was at the CCBC Fab Lab, and there was a woman there, and she came up to me, and we started talking, and I said, "What do you do?" And she said, "Well, I work for Towson University, and I'm going to create a lab over there called the Object Lab." And I said, "Oh, I'm with the Regional Manufacturing Institute." So that was the beginning of a partnership that shows that when you have the right people coming together with the right ideas, you get the right thing done. And so here we are several years later, great conferences behind us, great relationships with Annapolis, and we have in Maryland something that didn't exist before, and that is a voice and a movement for a new technology that clearly, as you all know, is going to help shape manufacturing. It's one of many, though, and as the advocate for manufacturing, and for 20 years, I've been out there and I haven't done a good job because we still have a lot of work to do. But we have a lot of friends in this room that understand what I'm talking about. I'm really hopeful that projects like this, especially this, are helping the public at large to see what I would call the new image of manufacturing. This is a sign we had when we were in Annapolis. It really is, Ken Birch has heard me say many times, the most important issue for manufacturing in Maryland is image. Image is everything. 3D Maryland and the work that Jan is doing goes beyond image, but it does help people to understand that manufacturing in Maryland has a future and it's going to be different. So there's a new design for the future of Maryland manufacturing. Many of the speakers here are members of RMI. Jan is on the board of RMI. I want to thank her and Howard County for allowing RMI to be a part of this. And these folks have got a great story to tell you today. So thank you very much for allowing us to be part of this, Jan, and congratulations on a great success with 3D Maryland.
Great. Thanks, Mike. So I want to underscore something that Mike said. There's a lot of incredible wisdom in the room today. So please take time after the panelists talk to network with each other. There's a lot of people in the room that know a lot about these technologies, and I want to make sure that what we're doing is bringing people together. Judy Lohr, Ken Birch were early forerunners here in Baltimore with the Fab Lab at CCBC. If you guys will raise your hands, people know who you are. And like I said, next line is here is a service bureau in the state, so we are really moving along. All right, so let's get on with the show. I'm going to do intros for each of the panelists right before they speak, but let me just give you a sense of who's on the panel. So starting all the way on the far end, Luke Chow from Prime Technologies. Prime Technologies is a Howard County business. Tylen Chop from Stanley Black & Decker, and you might have seen him on our Fox 45 live coverage yesterday morning. Al Romack from Bose Fluidics Corporation, and again, the wisdom sitting in front of you is incredible. And John Danko, Danko Arlington Foundry in Baltimore City. So we're going to start with Al Romack. Al is a principal engineer at the Bose Fluidic Corporation in Columbia, Maryland. One of Al's responsibilities is to manage the 3D printing and additive manufacturing lab at Bose Fluidics. For the last 7 years, he's built up the lab and worked to integrate the technology into Bose Fluidics business practice. Starting with their first photopolymer machine, Bose Fluidics has expanded the use of the technology beyond rapid prototyping design samples for the engineering group to functional prototypes, assembly aids, jigs, and fixtures, and has recently been exploring parts fit for use in the assembly and injection molding operation. Bose Fluidics has expanded the lab over the years to include 3 machines from photopolymer to FDM. The lab has been very successful and the machines run almost constantly. In addition to the management of the 3D printing and additive manufacturing lab, Alan serves as an R&D engineer and manages the Bose Fluidics 3D metrology lab. And also, finally, Alan has also had a 3D printing workshop at his home with a small FDM machine, has recently added a low-volume filament extruder to create custom filaments for his family and friends to use. I could go on about Al. I mean, that's a really great snapshot, and I just tell you, that's scratching the surface. This is one of our strongest advocates. He is probably maybe more passionate about the technology than I am, although it might be a rivalry there. And he's also on the advisory board for 3D Maryland, so please, welcome Al.
Hi everybody, can you hear me? Do I need to use the mic? Fine. Excellent. All right, well, what I'm going to do today is Jan asked us to talk about 3 basic things and how the technology has made Bose Fluidics better. Things we didn't know when we started using the technology that we know now and we want to share so that you guys have the same knowledge. And some of the best practices with AM3DP. And since that kind of stuff is so dependent on the machine that you ultimately get, I'm not going to talk about that, but I'm going to talk about best practices as regards to how we employ additive manufacturing as a process. So I'm going to talk about that kind of stuff, not machine-specific stuff. All right, so to give you a little background, we're an automotive supplier. We make an injection mold parts, assemble them for the wet system on a car. So that's from your reservoir bottle up to your nozzle that squirts the fluid on your windshield. Our lab has been in existence for about 8 years, and we have 3 different machines now. Among those 3 machines, we've produced over 12,000 parts for our internal and external customers. Our external customers aren't people we sell stuff to as an RP, but we sell a final product to, and we may provide RPs to them to understand what our part is going to look like for them 4 years in the future, since an automotive design cycle is around 4 years long. I have a lot on the slides, so I'm going to ask you guys to read, and I'm going to try and focus on just 1 or 2 things per slide so I can keep it in our 15 minutes. So we use RP for a number of different things. We use it for what everybody kind of expects in the design practice to help us communicate concept and design. But we also use it for a lot of other things, like once we get parts off of tooling, we will actually create small assembly fixtures. I've got one right over on the table there, where we print out the assembly jigs and nests and fixtures, and we try making the assemblies before we commit a lot of capital to hard tooling for the assembly fixtures. In our assembly process, we actually do things like make master samples for product reference. So for example, we make a lot of hose assemblies. And these hose assemblies get connected to various locations in the car. Some of them are made out of rigid nylon and they have formed bends in it. It's very nice to look at that on the screen and see a nice 3D bend, but it's very hard to visualize it and conceptualize it. So we'll actually print out entire hose assemblies with the grommets in place and everything else, and now we know exactly what the assembly is supposed to look like. And we'll use this throughout our process. Our industrial engineers will pick it up and they'll go, okay, this is about how big it is. They'll try out packaging, they'll do all kinds of stuff with it. We also take, and Bill, I have on the table over there, inspection fixtures. So early in the process, we're not exactly sure how we want to inspect this part. How do we guarantee to our customer that this part is correct? And we'll RP fixtures and jigs to hold everything together. And then we're really, really sure how we want to do all the inspection. That's when we'll invest all the money and time in building hard tooling, which would be all out of steel or aluminum. Injection molding. This is where I kind of want to spend a little more time because we're really excited about this kind of idea. For years, we've used it just in the design phase. And now recently we've integrated it in our tech lab or our prototype lab where we build the assemblies. Now we're starting to see how can we push this out to our core business, which is injection molding. So one of the things that we've done recently is we've actually started creating end-of-arm tooling that we put on the robots on our presses. Typically, that tooling would be made out of aluminum, and we can't do too much complex stuff with it because aluminum weighs a lot, and these end-of-arm robots and pickers usually have payloads around 2.5 pounds. What we've done here is we've actually created a manifold system where each one of these tubes goes to a separate cavity in the die face, and we're able to now separate our material out by cavity, allow it to drop into parsed boxes. Those go off to inspection and quality. They inspect the parts. If the box is good, it goes on its way. If it isn't good, they can contain that one cavity. In the old days, all 8 of those cavities would have gone into one box. If they found something wrong for cavity 1, they'd have to go through and sort every single one of those cavity 1s out of the box. Sorting is only 80% effective, so 20% of that product will get through to the next assembly stage. That causes a lot of troubles. So things like this is fantastic. If you guys have any thoughts about how you make that out of aluminum, let me know, because it's very complicated to make all kinds of extra detail, and we can just print exactly what we need, and that's very exciting. Another thing we have been exploring lately is custom tooling. So it's a little set of pliers, and it's specifically designed to pick this plastic piece out of the injection mold. Occasionally this piece gets stuck in the injection mold. You might be tempted to grab a pair of metal pliers and pull it out. When you do that, you damage the mold. It costs about $18,000 and 3 weeks to fix it. We're able to custom tailor this plier to exactly match the part and pull the parts out. We haven't crashed this tool since we started making these pliers. We get about a 1.5 year life out of these pliers before we roll over them with a forklift truck. That's its main source of death. We're also, very scarily, but with some help from our friends down the road, starting to investigate using 3DP to actually make prototype injection molding core and cavity blocks. So instead of making them out of aluminum, maybe we'll print the core and cavity blocks, do very small runs, make sure the parts come out the way we want before we commit to steel there, because that's expensive and it's time consuming. We're targeting being able to go from, I need a prototype part in plastic, to parts off of an injection molded core and cavity block in a 1.5 weeks. That's our internal goal. So we'll have to see how it goes. I blew up my first mold, but I learned a lot of good lessons on it. I'll try it again next week. Things that we didn't know about when we got into it that we thought maybe you guys might be interested in knowing is that it's not just about a printer. You don't just get a printer and put it on the end of your table and it prints the parts out. There's all kinds of stuff associated with it. One of the ones I want to focus on a little bit is accessory equipment. There's all kinds of accessory equipment in having these printers. They need to be cleaned up. You might need to remove support structure. Depending on the kind of machine, you might need to have liquids involved. So when you're thinking about doing this, make sure you reserve a little spot in your mind for where you might put some of this accessory equipment. You don't really want to clean this stuff up at your desk in front of your keyboard. It gets in your keyboard. Believe me, the IT guys get really upset when they're picking little bits of resin out. Make sure you have a good workbench, plenty of paper towels. Because we're an automotive company, we're driven by paperwork. There's also quite a bit of paperwork, but I'm hoping a lot of you guys are smaller and not burdened by those requirements. But do pay attention to things like MSDSs and how you handle the materials, just to make sure that your employees stay safe. Oh, I messed this up. Oh, the other thing I want to bring up here is space. Give yourself lots of room. We started off with a little spot, and now you can see poor Chris here in the lab. Can't barely even move around. So when you buy your first machine, just automatically set in your head that you're going to buy a second machine in 5 years and leave yourself enough room for it. We're actually moving our lab to a new space because our president is tired of not having 2 of us be able to talk in the room at one time. Another thing that you should understand and think about really hard as you're getting ready to make your purchases about consumables. It's more than just the filament or resin that you put in the machine to make it. There's other things that are consumables. It could be build plates, it could be inject extrusion tips, that kind of stuff. Think about it, ask the right questions. I recommend you go out and find somebody who you can talk to who has the kind of equipment you want, and I think that's a great avenue for 3D Maryland to help you out with that. Because you can call Jan up and say, hey, I'm thinking of buying the EnvisionTEC 3SP machine. I want to talk to somebody who's going to give me the real dirt or the real scoop. And she'll say, yeah, sure, no problem. I'll give you Al Romac's name. You call him up, and we'll have that conversation. And we're here to help you because we want you to be successful. we love this equipment, even with some of the things that we have to go through to get the parts out. And we'd love to share what we've learned with you guys already and bring that forward. And what I think that leads us into is kind of those best practices that Jan asked us to talk about a little bit here today. I'm not going to run through all of them, but I'm going to run through just a highlight of a couple on it. Bowles has chosen to go with a limited number of users who use the machines. And we do that for a couple reasons. One, we'd like that user to be really in-depth on the knowledge of how to use the software. It's not just your CAD program where you design your part, but you also have to know how to use the pre-processing software for the machines. You want to use that all the time so you stay familiar with it. Our shop runs all of our machines practically every day. I come in on Saturday and Sundays to keep the machines running. And it becomes extremely important to be able to kit up jobs on those machines when you're running them almost at a production level, so that you're not just building one thimble because John needs the thimble and then Luke needs something else. You try and kit them up together so you take advantage of the time you have during the day. We actually run a 2-shift process. We do short run jobs in the morning, longer run jobs overnight, and then our big long jobs over the weekend. Also have a management champion, someone in your company who's passionate about it and is willing to support you and push that along. Because it's always nice not to be the guy at the bottom of the ladder saying, I want this, but have somebody at the top who are looking down on you going, I want you to do this. That's been really helpful for us. We have a really great management champion in place. The other thing I would advocate for is to have some kind of work order system or a spreadsheet. Again, if you're a really small company and you're just doing 1 or 2 jobs, it's not a big deal. But if you're we service up to 40 different requesters in our company among our design engineering groups, our manufacturing engineering groups, and our quality group. To know what they're asking for, how many they want, and when they want it, really important to get all that information up front so you have a good, clear communication path. Because you're then going to turn around and ask someone, John or Mark or whoever's working in your lab, to try and manage all that information and deliver stuff on time. And the beauty of this, of having this in-house, is that there is hardly any time in it. If I were to go to a service bureau, it may take me 3 or 4 days to get the part back. I can usually turn stuff around overnight, but we have to communicate clearly what we're doing. And we found that a nice spreadsheet or a work order system is really good for that. We actually use a SharePoint list for it, and it works fabulously. I also recommend making clear expectations on when your jobs are going to be submitted during the day. So that if you're going to start your job every day at 9 o'clock, somebody isn't coming in at 10 o'clock and think the machine's open to work on. Just to set some expectations for your requesters in the system. So I'm going to summarize now because I don't know how close I am to my 15 minutes. But it's a powerful, powerful tool to add to your arsenal. If you guys design stuff, you're going to try stuff you never thought of before. We used to send out about 300 parts a year to outside service bureaus. And now, like I said, we've done over 12,000 parts. And we'll test things we never thought we'd test. And you might say to yourself, well, that's kind of silly. Why would you do that? I can't tell you how many times I have tried something that I never would have designed normally that would have came out as my final product. You can do little DOE studies where you change 3 little things on it, print them all out, try them out, and find out the one you thought you were going to make isn't the one you're actually going to make. It's this one over here with the unexpected benefit that you would have never seen if you had made yourself a whole bunch of different samples and different design iterations. And let me leave you with one thought. I don't know how Bowles Fluidics could do its job today without it. We use this thing everywhere for everything. There isn't a design review that our team doesn't go into and have a part to put on the table and look at. There's not a customer visit our engineers don't go on where they take the latest version of whatever the part is up there and hand it to the customer and say, this is what we're thinking about. There's hardly even assembly equipment anymore that they don't try out bits and pieces of it beforehand, before they put it in the actual machine shop to make real parts. So once you start, you'll never imagine how you live without it. It's kind of like having a computer. You never imagine how you didn't work without a computer before. That's all I have.
Was that not fantastic? Okay, we got 3 more of those. Thank you, Al. That was really fantastic. These guys, like we said, they have a wealth of information. We just want to share that with you guys. As we're getting set up for the next one, I just want to call your attention to, we have this narrow sheet here with some of our upcoming programming on it. Two things that are not on it, which I'd love if you would add to it. We are going to host 2 SolidWorks user group meetings here at the Innovation and Prototyping Lab. The first one is on May 22nd, and the second one is on June 19th. They are from 5:30 to 9 in the evening. At the end of the day today, or at the end of the program today, at 9:30, we will give you a tour of the Innovation and Prototyping Lab here at 3D Maryland, and that's where the user group will be held. And if you're a tweeter, you can tweet about both 3D Maryland and RMI. 3D Maryland is at 3DINMD, 3DINMD, and RMI is RMI of Maryland. Okay, next up, John Danko. It's always a pleasure to, who's up next? Luke's up next? Oh. My advisory board is in charge. Luke Chow is President and CEO of Prime Manufacturing Technologies, located in Savage, Maryland, in Howard County. He's a chemical engineer by training from the University of Pennsylvania in Philadelphia. He has held various positions with Ally Corporation, from R&D to manufacturing engineering. After many years in corporate America, he decided it was time for a change of scenery and moved from Pennsylvania to Maryland. In 1991, he started Prime Manufacturing Technologies, doing plastic injection molding, composites, and CNC machining, with an emphasis on lean, agile manufacturing processes. Rapid tooling and prototyping has always been on his radar, and he's been an early adopter of 3D printing since the mid-1990s, and has observed the application and evolution of 3D printing. Luke lives in Bethesda, Maryland, and can be reached at lchow@primemanufacturing.com. Thanks, Luke.
Good morning. Thank you very much for coming in this early to listen to us. We do Prime Manufacturing Technologies. Let me see this. Is this my? Okay. All right. Here we go. So what I'm going to cover. Okay. I'm sorry. Let me get this out. Yeah, what I'm going to cover is a brief introduction to Prime, and then about the injection molding process, then the 3D printing, how 3D printing has evolved at Prime, and then some barriers and some benefits of the 3D printing. Okay, so Prime Manufacturing, we are a digital manufacturer, and we help clients to bring their products to market, and we utilize several various processes, including injection molding, silicone molding, composites. We also do metal injection molding, and depending on the client, we would use the appropriate technologies, and sometimes they're not familiar with other technologies. We would suggest to them and educate them about different options that they have, so that they would use the best technology to bring their products to market. Because ultimately, if they don't use the best technology to bring the product to market, they won't be as successful for long in the marketplace. So eventually someone will find the best technology and will compete with them. We serve in several industries. We do some medical products, some electronics, telecom, automotive, agriculture, and construction, and some military products. As far as the process goes, this is a typical injection molding machine. Some of them, let's see, oops, sorry. Is your, I think I prefer this guy. Okay. So you have a hopper where the raw materials go in, and then a barrel here where the material gets melted, and then it's injected. This area here is the clamp system where you mount your mold in this region, and then this is the clamping that moves back and forth as it cycles, producing parts. Some of the, oh, okay, that's okay. So this is a cross-sectional view of the machine. So here's your hopper where raw material comes in. There's a screw here rotates that feeds the material in to the front areas. These are the heaters, external heat. So the plastic is melted through external heat as well as frictional heat in there. So, and here's your mold is mounted to this platen. And this is the other half of the mold mounted on this half of the platen. And this platen moves back and forth. This is where your part is located, your plastic part. Okay? So when plastic is then injection molded into this cavity. These are just cooling lines. So that's a typical injection mold for molding machine that some of you may not be familiar. And this is an injection, part of injection mold. And you can see there are many components that make up the whole mold. These are some of what we call cavities, and these are your mold frame. So when you make your part, this is where your part shapes come into play. I mean, that's what gives you the shape. But the rest is all supporting material. So the mold making process is a complex process. And it goes through this process, a typical process. We start with a 3D model of the product. Then we design the mold, and including all those components, the cavities, cores, and all that. And then determine what type of processes is going to be involved using to produce those components. And the third step is to fabricate all those cores, cavities, components using CNC technology. And CNC technologies could involve like CNC mill, lathe, CNC EDMs, wire EDMs. They're all computer numerical controlled. So over here is a picture of how a cavity is made. This is the mold block, and the part is in here, the shape. So these are electrodes that we use an EDM process. This is graphite, and you shape your part into this block, and then you use a process called electrical discharge machining to burn that image or that shape and details into the metal block. Then there's some features that you don't want to include in there or cannot include in there. You will make them into separate electrodes and burn them separately to achieve an overall part. This mold happened to be this one. It's for a helmet. And it has, even though it looks like there are some flat surfaces in it, this part actually has no flat surfaces on your normal Cartesian coordinates. Every surface is it's not flat. Yeah. So the evolution at Prime, we've been using before the, we've been using this technology for about 20 years now. But before 3D, this was a rapid prototype. The customer would use metal. They would hammer something to a shape that they want to convey the idea to us, and some dimensions. So, we would take this sheet metal shape and then create a 3D model from which we would then use CNC and machine them out, the shape of the part. And then we'll give it back to the customer and say, hey, is this what you want? And they would verify it, and this would, sometimes take a week for us to, convert it from the sheet metal to a 3D model in the CAD, and then program it and machine it. So things have changed quite a bit since. So we primarily use the 3D printing for fit, form, and function. Since the new capabilities of 3D machinery, equipment, and materials has developed recently, we're now using 3D printing to fabricate molds or cores and cavities for faster delivery of injection molded parts. So the significance of this part here is that you're actually getting injection molded parts very early on in your product development stage. So you actually can test what your final process is going to be. The product, what your final process is going to be like. All right, here are some examples of these. This is that hammered one, and this is the CNC machine one. And then we moved on to this is a laser sintered part, and this is injection molded part. This is also a stereolithography, and this is injection molded part. Okay. This is a part that we made. Is a connector, injection molded, and this is the 3D printed core and cavities. Using 3D printing, you gotta know where you can use it and where you cannot use. There's some features that are just way too weak using the straight 3D printed material. So what we do is that we reinforce them with, replace those features with metal inserts. So using that, we're able to keep producing. We produce a few hundred of these, and the mold is still in very good shape. In fact, it's right here. So, under normal circumstance, this would take you about 3 weeks to do it, and 3-4 weeks sometimes. But using this process, we could do it in 3 days. So it's a substantial time saver, and also a substantial cost saver. Some obstacles and barriers. Well, high cost of equipment. High cost of the equipment, gives you a low rate of return on the money. So it is sometimes you wonder if you justify doing that or just use a service bureau. Limited selections of universal material is also a limiter. You have only X number of material to use. Lack of high strength and high flex modulus material for non-metal 3D printers. If there were some higher strength material that we can use, we can make parts that have more details in it, finer details instead of putting metal inserts. You can just print it, and it's strong enough to withstand the injection molding pressure. Inside the molding machine, you can go from 50,000 psi up to like 40,000 psi. But normally in 3D printed molds, you don't want to go to the 40,000 psi. Elders learned. And let's see. So, yeah, the time saver benefits of 3D printing, what we find is, it's a real time saver. And you could be the first to market. Cost savings, production, quality parts at prototyping stage. So whatever you have at hand is much stronger than a 3D printed part. So you can actually do actual life testing with it. Minimize human errors because you're now not depending on human to make all those components for the mold. You can now print them out. Especially when we move towards the metal injection molded pores and cavities. That's a real plus. Plus you get conformal cooling on top of it, which is really nice. Easier to train new employees. Of course, they have to have that drive to learn. And so the as far as 3D printing goes, we're very optimistic on where things are going, and the sky's the limit, really. There's a lot of things we can do with 3D printing. As you all have read, there's in the medical field, people are printing skins, for surgery, for implants. The sky is really a limit. So, and if there's anything we can help to share this technology, come talk to us. We'll help to, again, advance this whole technology. Thank you.
All right, John Danko, Danko Arlington Foundry. John was born and raised in the homeland neighborhood of Baltimore City. He's a graduate of the Gilman School. He received a BS degree in mechanical engineering from Lafayette College in Easton, Pennsylvania. Studied various theology and philosophy courses at Mount St. Mary's College and Seminary. He was a quality control manager and chief engineer at Danko Arlington prior to becoming the third generation president. He's a member of the American Foundry Society and the Non-Ferrous Foundry Society. He's a pioneer in the use of additive manufacturing in the foundry industry. He's a founding member of the 3D Maryland Advisory Group. We're very grateful for John in many ways. And what's not in John's bio is that, and I'm sure he'll talk about this, is Danko Arlington is a 94-year-old family-owned Baltimore company. And I saw a presentation from John just the other week and really talked about the innovations that each generation, his grandfather, his great-grandfather, his father, his grandfather, his grandfather, his father, and he made generation after generation with technology. And it's John is just an amazing story. So, John.
Okay, thank you, Jan. I'm going to shake things up a little this morning, and we'll start off with a little movie, very short 3-minute movie. Stratasys is our machine manufacturer, and we've become a poster child for them because of our niche industry in the metal casting foundry business. So I'm going to run this little clip, and then we'll go on and show you some examples. Okay.
Hi, my name is John Danko. I'm president of Danko Arlington. We're a unique company located in Baltimore, Maryland. We've been in business since 1920, and we make aluminum sand castings, industrial patterns, and machine cast components. We're unique because Danko Arlington sells to military and commercial customers. We're strictly in the sand process right now, and we are using FDM printing for a variety of applications in our company. Danko Arlington chose to enter into additive manufacturing because there's a scarcity of pattern makers today. The pattern makers are the tool and die makers, the trade that makes the tooling for the foundry. Today, that's a very, very scarce talent. So we were using CNC machining to make up the difference, but even today, CNC pattern makers and CNC machinists are scarce. So we are now embracing additive manufacturing with machines made by Stratasys to fill that gap. At Danko Arlington, we have small volume, high-quality production. And that's where FDM comes in. We are able to make patterns for small quantities out of ABS or PC10 plastic and incorporate them into small runs from anywhere from 1 to 100 pieces. In using FDM printing for pattern making, you don't have to worry about a rotating cutter. So what you can envision in CAD is what you can print. So you can print, for example, square corners, fillets, locating pins, backdraft, and even odd parting lines.
We can make a loose pattern, try out our gating, decide which side we want up, which side we want down before we invest a big investment in a mounted pattern. Traditional pattern making takes a lot longer. I mean, jobs that take months, we can make in a matter of a couple of days.
The FDM process is extremely accurate. Our sandcasting tolerances are generally plus or minus a 32nd. Sometimes we go to plus or minus 20. The printer prints anywhere from 3 to 5 thousandths of accuracy, so we're already a fraction of what our tolerances are. So if we make a tool, for example, that's closer to size and nominal, then that leaves a lot more leeway in our process to have a better casting. We're also using FDM to make drill bushing fixtures, straightening fixtures, and check fixtures. So we can take the CAD that we have made for the casting and we can superimpose another design on top of that to make a check fixture, for example, for core setting or for straightening, and even to drill holes in castings after they've been machined. So it's a great time saver and also very accurate as well.
Usually, when we first get a job, we have to quote film cost on it because that's part of our expenses. And I typically will work from a two-dimensional drawing or blueprint. It's sometimes hard to visualize thicknesses or positioning of the part when we do various X-ray views. Having a 3D model that's printed for us, we can actually mock up our real shooting just as if we had the actual aluminum casting. And I can estimate better where the camera angles are going to be, sizes of my film, number of parts on a film, and that helps me get a more accurate cost, which helps us get a better price at the end.
The unique thing about FDM printing is that you don't have to be trained formally as a pattern maker. You can be a draftsman or a CAD engineer, and you can make patterns from what you see and what you draw on CAD CAM. One CAD CAM engineer can do the work of 5 or 10 pattern makers. And with 2 FDM printers, we're pretty much doing the same kind of work that we did 15, 20 years ago with 15 pattern makers. The FDM process has enabled our foundry to meet shorter lead times and make castings faster. We're able to print patterns in a matter of days or even hours as compared to weeks or months.
By the way, that casting we made, the Cosworth cover was for Jay Leno. He's a big advocate of 3D printing, and he has a car collection. And that was one of Stratus's toys for Jay to help him with his car. So we'll start from the beginning. Okay, so the first slide. Right here. So Dank Arlington is aluminum foundry. We also have a pattern shop and a CNC machine shop, and our primary customer base is defense, military, and high-quality commercial castings. We've kind of grown in this niche because we've been around Washington a long time, and we have tentacles into the Department of Defense and major contractors here in Maryland. So this marketplace is the reason why we're still in business. Most foundries are out of business in the United States with offshoring in Mexico and China. So a barrier really is with the whole defense system now in the United States. We're getting into small quantities, spare parts. So we're not doing the high runs that we did in the 50s, 60s, 70s, and 80s. We're now doing spare parts. So FDM comes in to that play because the new tooling, if you want to get into a new market share, you're only talking about a couple pieces. So with a high amortization for a new pattern or tool, it's pretty tough to break in there. And FDM has enabled us to break into new market share. So another barrier I cite is an aging workforce. As Jan said, we're 94 years old, and we have a lot of workers that have retired, and we have trades that are not being taken up by young Marylanders. These are the apprenticeships for machining and pattern making and foundry. So nobody knows what they're doing today. So how can you grow a business when you have no skilled workforce? And this is another RMI issue that we're working with Mike in. What are we going to do? We can't bring people from Ohio and Michigan and Iowa into Maryland, because Maryland's a high cost of living state, as you know. And so it's a tough position to be. How are we going to grow into the next generation without good craft? Just to let you know what pattern making is, it's a die or a wooden model of the casting, which we press into sand. And we used to make patterns out of wood because wood is easily carvable and you don't need a lot of equipment to work it. But could you imagine these pattern makers making this die out of mahogany here by sawing and sanding each piece and gluing and bolting it together to plus or minus a 32nd of an inch? That's the tolerance that they have to maintain. So it's a skill that's really no more. And so where we are right now is in 2010 we bought a Stratasys 900 FDM fused deposition modeling printer. It has a very large envelope of 36 by 24 by 36 high. And we bought it because we wanted to do all of our tooling in one integral piece and not bolt things together. So it's one of the largest printers made today, and I consider it the workhorse of the 3D printing. And we use polycarbonate plastic for it too. So the benefits that are, as Al and Luke had mentioned, unlimited new possibilities for design. We can print all sorts of pins and components that we never would have been able to do with a 3D rotating cutter. Here's just one example. This is called a core box. And a core box is like an ice cube tray. Instead of filling your ice cube tray with water, we're filling it with sand mixed with glue, and it's going to make a core. So this cavity is going to make a piece of sand. That sand is going to go into the mold, and it's going to make the inside of this casting. And this casting, by the way, is a control stick for the T-38 aircraft for the Air Force. It's what the pilot steers the plane with. It's a sand casting that dates in design from 1960 from the Northrop Corporation, now being purchased by the government as a spare part. Another benefit for printing, obviously, is no programming and no operating setup. As I mentioned, we were making up the difference by CNC machining molds, but if you could imagine, if you had to profile and cut this out of a piece of 6061, that's a lot of work, and that's a lot of programming time, and it's only one piece, it's one tool, one piece. You're talking maybe 2 weeks to make this on CNC. Pretty tough, not to mention it might twist or warp too. So we replace that with the 3D print. Another efficient process is really just the footprint, and we're an RMI Green Team member this year. But what about the greenness, the sustainability of having two machines place a 10,000 square foot wood shop? Talk about the enormous impact that has. We now have an empty shop. We have 2 workers in the shop right now, and all they're doing is painting and sanding FDM parts. So we don't need it, and we're looking at other purposes for it right now. So one shop replaced by 2 machines. Another barrier that we have encountered is just the cost of material. You probably already know so already, but this stuff is expensive. And here's a block of wood, which we call a board foot, which is 12 inches by 12 inches by 1. That's what the lumber industry uses as a standard for costing. So a board foot of lumber, poplar, is about $2. And then you go to plastic for 60/61, you're up to $10. You're up to $20 and maybe $60 for 60/61. For a solid 12 by 12 by 1 in polycarbonate, it's $600. So you really have to watch your material costs when you make. This particular large core box is made out of styrofoam. No way could we have done it in FDM. It's just too expensive. It would take months to print. So it's just a big piece of styrofoam machined out. Another disadvantage really or challenge with the FDM is it cracks. And we've got a really tough workforce that uses clamps and hammers, and if you crack this stuff, even just tightening this down to the board can cause a crack. So you got to be really careful in handling this. Another challenge is really, you have this beautiful printed object within ±3, and then you got to hand sand it and paint it. So we don't have high skill to do that, but obviously if you mess it up, you're going to ruin all your tolerances. So maybe someday they'll have a better finish than the stair stepping that you get with this, because it's going to hold the sand inside the pocket. So what we've been able to do is with existing customers, including right here at Northrop Grumman, been able to replace their worn wooden tooling with new FDM tooling for a fraction of the cost. And it's a win-win for Northrop Grumman, and it's a win-win for Dank-Wellington. And it's not huge runs, but we're able to make new tooling off this new process, relatively inexpensive. We've also been able to get a lot of new awards, as I mentioned. T-38 aircraft, we have now over 24 parts on that plane, and it's an Air Force initiative right now to rebuild that plane for cast components that were out of magnesium. These parts were designed in 1960, and they had a death, they had a failure about 6 years ago. They had a crash, and the plane totally disintegrated, the pilot was killed. So the Air Force has this new initiative where they're replacing all the magnesium parts in this plane with aluminum, and as a result of FDM printing, we're able to make tooling very inexpensively, and we're able to beat out the competition, including Northrop Corporation, Northrop Grumman, to make these spare parts, because this stuff is so cheap. We can make this so quickly. Also, we have a lot of new interest from young people, which is really, really cool. Because we have 7 smokestacks, and we're considered old primary Maryland manufacturing. We have new hires from Stevenson University up the street. We have hired just recently an engineer from UMBC. And we work with Johns Hopkins University on their Baja car, which is their dune buggy. And we even had all the mechanical engineering classes come out to the foundry in February and cast their own components, their drivetrain for their car in the casting world from 3D prints that we provided them from their engineering. So lastly, it's just a great story that we have an old company that has running out of skill be rejuvenated with this technology. So we're kind of, I guess, the face of maybe manufacturing for tomorrow, complementing the old and the new. We are not printing castings yet. You can't print this because there's too many areas of fracture of lines that's going to cause the part to fail. But we're getting around it by printing the tooling. And then the tooling makes the cavity for the sand, and then you put the molten metal in the sand. So we're getting around it, but probably 5 or 10 years, this part will probably be 3D printed in metal. X-ray grade, X-ray quality. So that's the future where we are right now. So thank you very much.
Thanks, John. That was fantastic. Thank you. All right, and last but not least, Tyler Chop is a senior industrial designer at Stanley Black & Decker, which is a $2.6 billion S&P 500 company. It's a diversified global producer of hand tools, power tools, related accessories, and mechanical access solutions with 2 locations in Towson, Maryland. Tyler is trained as both a mechanical engineer and industrial designer, has been the lead designer for over 25 consumer products. He specializes in combining technical, ergonomic, and aesthetic user requirements into product solutions. He's also the team lead for the Suzhou Consumer Industrial Team in China. So, welcome, Tyler.
I'm going to walk through sort of our process at Stanley Black & Decker. The first thing I want to show you is just what equipment we have, and this is actually just the equipment we have here in our Towson facility, which is Legacy Black & Decker's headquarters, which is now our CDIY headquarters for Stanley Black & Decker. So sort of the workhorse from an industrial design standpoint is we have 2 D-Core printers, just like the one they have in the lab down the hallway, and 2 Eden Object printers. So both of those types of machines are used from industrial designers, for us pretty constantly. The D-Core machine, both of them run basically all day long. We have one FDM machine that we use sort of in tandem with our innovation team. So it lets us get early model prototypes, functional prototypes. We're going straight for that. And then our engineering facilities has 2 SLS machines. that they also run constantly. I think it's like a 2.5 or 3 week wait just to get parts through these machines because they're running nonstop. So just to talk briefly about advantages to this, first from an industrial design standpoint, versus our old process. So we used to do CNC foam models out of Ren foam, and that would take about 35 to 40 man hours, and you usually need someone there with that machine. And there's setup time, and you don't want to leave a CNC running with nobody in the office. It's kind of a dangerous thing. So now what we use instead of that is the Z-Corp models, and total time's 8 to 10 hours. We run builds pretty much every day at 3, so overnight they run and they're cleaned up in the morning. Our model shop guys are cool enough to get in earlier than us, so when we drive in the morning, you can actually pick up your models. It's like an overnight type of service. And it only takes about like 4 man hours, so they can focus on some more complex things than setting up and cleaning up a foam model. Traditionally they would have to sand and paint those foam models as well. So now we print the Z-Corp prints. They're in color also, and they're actually pretty high resolution, so you don't see the lines that you see on SLS machines and things like that. So if you want to evaluate something aesthetically, you can do that really easily or ergonomically. And we also have some ways of actually matching weight on things like this to get a weighted model and get something pretty accurate. And one other best practice sort of gem for this, we've actually started printing to save on material costs, as you mentioned. We've started printing wall thickness parts in the Z-Corp, and if anybody's familiar with it, it's really fragile. It's like a chalk. But if you use wood hardener, it actually becomes a little bit more durable, and it's something that we do that. So we use maybe 1/6 of the material we used to use for a Z-Corp model, and we just impregnate the whole thing with wood hardener afterwards, so it becomes a lot more solid material. So our marketing guys don't break them off. So yeah, it's a lot faster than what we used to do, and yeah, I'll get onto the Eden part. The other thing we used to do is final models. That's what this guy here is. This is an Eden model that we do now, but we used to do this by hand with Ren foam, painting, the same process I mentioned before, but very, very final detail. And that's 35 to 40 man hours, and the total time is close to 80, it's almost 2 weeks basically to get a model like that. And it's a lot of work to produce. Using the Eden machine, we can produce these parts. There's still some post-processing. We soak the parts in lye afterwards because there's like a film that's left from the Eden machine, and that makes it a lot easier to sand and paint. But it takes about 25 man hours to produce one of these. And another sort of advantage to this is we use these models before we actually have early ESL samples of manufactured parts to produce the packaging imagery. So we used to do this all the time. If you want to do, now we only do it if you have an application shot or something that has to look like it's actually functioning and in someone's hands. The process we use for packaging images now, we just started this initiative I think almost a year and a half ago. We use KeyShot, which is a 3D rendering software to produce our final package renders, which is also really, really cost effective and saves us a lot of time. So, and it's a better result than photography most of the time. So I've already mentioned some of this stuff, but I'll go back through current uses for this. So this is a project I worked on under the Porter Cable brand. We basically, like any idea I have for an ergonomic solution for this was a cordless circular saw, handle position, auxiliary handle, all that stuff. I can model it and we can test it, and I can probably get 3 models by the next day to evaluate, which would have taken, if you think about that many iterations or that many options, would have been 3 or 4 weeks worth of work. So we can really refine things. I mean, even before we start adding detail, you can see we're refining ergonomics and layout of engineering parts at a very early stage in the project, and we can evaluate it pretty tightly. We also use it for aesthetic evaluation, so when we start to get design details and things like that, into the product, you can see the one all the way on the right. It's pretty representative of what we're going to use for tooling. Another benefit for this is scale assessment. So there's been a lot of times that not just myself, our engineering staff, or even I worked on a freelance project with a team in Maryland, and everyone had an idea of what they want, dimensions of the things they wanted, and what sort of tolerances they want. And when you're trying to please everybody, you might end up with something that looks great on screen, and you print it, and it is a lot bigger than you thought it was, and you're like, I'll never sell that. So it kind of gives you that reality check really early on, so you know where to push and where not to push, or even if the idea is, worthwhile. So that's something I think gets missed a lot, but yeah, the scale is something that is really helpful, especially with the speed. We also use it, but like I mentioned, the engineering team has SLS, and we use the FDM machine for functional prototyping. So, and sometimes we may jump straight from CAD to a functional prototype if we're familiar with the components or the layout, something like that. And we use that for preliminary testing, and we also use these for user research. And like I mentioned, the photo model. This actually gives us a really good chance of making sure what we have as a final result is worth the tooling investment. So before if you wanted the tooling on this circ saw is somewhere around like $250,000 or something like that for the actual injection mold seal. So before you want to spend that much money, before our business wants to spend that amount of money, they want to make damn sure that they have exactly what they want. So here's a couple slides on sort of the ergonomic evaluation. And one of the things we do here too, there's a sample on the wall over there. We'll take real components and we'll print the Z-Corp model, which is pretty cheap, and we'll cut out cavities for where the components go, and we'll put them in there so you can feel how that feels with the actual trigger. There's some really sensitive ergonomic areas when you get into lock-offs and triggers and the trigger lip and things like that. And I think the model over there even has an Eden printed trigger cap, so combining the two technologies together can also give you some really unique benefits. I mentioned this before as functional prototyping. This is a program I did for Bostage, and what we did is this is our engineer's model basically. It's our final surfacing with the engineering components, and we build and test these and we put them out in the field before. I mean, it doesn't have the exact material properties of the final product, but it's pretty close. It's a lot closer than not having anything or just trying to make something. So we use it for that, and again, mixing technologies. The belt clip on this particular tool, we were looking at different, what kind of bits you want to store and how that's going to work, and we use real clips, metal clips, real screws, and then an Eden clip, and then it's actually a Z-Corp model to test the thing out. So you don't have to go all the way to SLS for everything and pay for that material, or even Eden. We've been able to utilize the Z-Corp, which is cheaper, to evaluate some of these things, or by using a combination, we can evaluate it pretty quickly. Although I think the wood hardener helps with that. And you can see, actually, this one in the top right is our SLS. It's the same model, it's just been painted up before we send it out to users, so they don't know exactly that it's just an engineering prototype. Aesthetic evaluation, I mentioned that. It is nice to see, sometimes we get into these little details and things, and you may end up on a sharp edge, or you want something that shows up in 3D and it may be too subtle. Like we found, if it's not 15 degrees on a brake line, you probably won't see it. So that's something that you won't know. You'll see it in CAD every day, you can render it and you'll see it, but when you see a real part, our rule of thumb is if it doesn't show up in Z-Corp, it's not going to show up in the tooling. It's too faint. And then, results. We get a highly refined product in the end without any investment. So you don't have costly mistakes, you're not doing steel safe changes, you're definitely not scrapping any tooling. I still want to work here. And you get a really fast development time. So, and this is an example of eShot rendering, so that was done for the packaging ideas. That was pretty quick, I guess, but.
All right, now it's time for you guys to hit them with your best questions. So we have about 20 minutes for question and answer with our panelists. So who's got a question?
I'm just talk. I heard a consistent word, prototyping. I heard lab. I heard interface with the mold process, the injection mold process, but I didn't hear anything a great deal about discussion about on the floor. And what are some of the hurdles that you see amongst the different machine makers that prevent that transition, besides the cracks in the mold and the resin material? Because if you look at 3D printing in the last 3 years, there's a double-digit difference between the number of printers that they sell in terms of their SEC reported numbers and the amount of resin material that they sell. So if 3D printing were truly taking off, I would expect more resin material to be sold than printers. It's the other way around. What needs to happen to change that?
That's a tough question. That's a very good question.
I think parallel processing would help. Right now, because the 3D printing is layer by layer, and that is your limiting factor. So if you can do a parallel processing, you can do simultaneously build, then you can speed up your throughput.
When you say parallel processing, I mean more than one head working on it?
Independent head.
Yeah.
More than one independent head.
So that you would speed up the whole building process faster than what we do now. That would be one option. There are probably some other ones.
Also, as I said, it's very expensive material. $600 for a cubic, for 12 cubic inches of material. You're not going to buy a lot of material if you're going to use it. Or we're tie your printer up for weeks to print something huge. You're going to print it as a shell as thin as possible. And there's still other manufacturing methods for prototype, hogging out CNC, which is going to be more cost effective if it's a larger part. You don't see huge parts because it's just too expensive right now. So maybe in 5 years it will come down. But there's a break-even analysis on your labor versus printing. And when you get something so huge, you really would tie your machine up for a long period of time, and then you have to sell it too. So it's just not effective cost-wise. So far as the shop floor, I think most companies now are just in the last 5 years, are just starting to get introduced more to 3D printing, smaller companies, and it's going to catch on. So far as on the shop floor as well, there's just not specs right now for materials. So you can't print, for example, that aircraft part out of plastic, or even have an ASTM type of printed plastic that's compatible with the ASTM specs that are out there right now for injection molded plastic because of the boundary layers. So there's a lot of research right now being done by printer manufacturers to find out it's not just the same material, but how you deposit, how you layer it, if you can be somewhat controlled by a specification to mimic what's out there right now in injection molding or other types of processes. Still good.
I got one for you. We, on our FDM machine, which is a plastic print, we were consuming 150 cubic inches of material roughly every 6 weeks. As we gained the knowledge of what that material could really do, what can the parts really do, we've been picking up our consumption. We're now up to 150 cubic inches a week. So I think some of it's an education learning process. And as you begin to learn and educate yourself what the material can really do, and you make a few mistakes and you break some parts, you change the way you design it, because designing for an FDM part is different than designing for a machine part. And I think we're getting that, you're going to see that acceleration in consumption now. I mean, like I said, we went from one box every month and a half to a box a week. And we're going to only pick up from there. I mean, more and more people in our company are adopting it. We're pushing it out to our assembly operations in Mexico, and they're starting to use the material there as well. We're going to consume more and more. So I think we're seeing probably the crest. There's all this education going on. There's all these people learning about their machines and figuring out how to optimize the use for their business practice. And then once they got that nailed down like we did, it's going to start cranking out. I mean, we're just cranking parts out all the time.
Niall, Was that, were those figures, the resin sales and the material sales from the OEMs or across the board?
From 3D printing. So that they would break out of their sales and then have printed material breakout.
The other thing I would say is there's a lot of answers in the audience, so if the audience also wants to chime in with information, please don't hold back. Oh, Tyler, did you want to make?
I mean, I feel like I had two questions there, I'm not certain, but I'm certain that we're using more material than the machines cost. We've been beat up by our finance department a few times. So I'm sure maybe some people aren't sure how to use it yet and they're not using the materials. But as far as, I think you asked, why isn't it being used for production of real parts? Is that what you're saying?
Yeah,
I mean, from our standpoint, you can't get the resolution and we don't know anything. I think this was mentioned at one of the previous panels, was that no one has any data on how these parts are going to hold up over time either. So because they're different materials and how they're bonded, so you end up with, you know, delamination and some like, yeah, not as strong. So it's coming, just maybe not there.
I think I have a question to the whole panel. So in Just Technology, we do R&D prototyping of sensors, which are very small, like anything between 1 to 4 inch. And not only that, our surface is also thin because we have to have electronics PCB pushed inside, such as 1 to 3 inch dimension. Now, 1 year back, I tried to do 3D prototyping, moving ahead from a traditional CNC machining. What we figured out as a big problem is that because strength of material for the polycarbonate is not that so high, we tried with 2-3D lab and it failed because of the very nature that is small, and then you have probably not even more than half a millimeter of surface that you can afford because the electronic PCB has to get into it. So considering that we are coming from a sensor background and we want to do sensor prototyping, maybe I am just looking for suggestion. Do you think that 3D printing is possible for that kind of dimension and challenge?
Okay, I'll take this one. We make windshield washer nozzles. They are small as my thumb, so we know exactly what you're talking about. That nozzle is going to be hollow in the inside because I'm going to install check valve components. I'm going to have a slot where I'm going to insert a fluid chip. I would not recommend at this time FDM for that because it's just too coarse and the material layers try to separate when you do it. And that's why we've invested in photopolymer machines like the EnvisionTEC machines. They are capable of printing those really small resolutions. You get really good part out of it, and they're fairly strong. I mean, some of the new materials that EnvisionTEC has come out with in the last couple of years, we're actually putting together entire assemblies of housings, interference fit assemblies, and popping them in the cows of cars and driving around test tracks at 100 miles an hour to try them out. I mean, there's definitely technology out there. You just got to kind of step back and think about what you want to do. You might not want to pick a machine that has thousands resolution, but start talking about the micron resolution machines, like 50 or 36.
Put on the front of that, the photopolymer machine is going to break down in ultraviolet light, including light emitted from fluorescent tubes in this conference room. So
The
over
old
time,
ones, the new ones not so much.
you have to be sensitive. Your part for 5 years at warehouse or sunlight, so you have to look at that. That's a trade-off. It might not last that long. You just don't know today.
Talk to me out.
Sure. Let me take you back to when you were first thinking about doing 3D printing and the ROI analysis. Is that something that was pretty clear the first time you looked at it, or did you look at it and see the ROI and then creep up on it? What was the sequence? How long did it take you from looking at the ROI first until you finally got to a point where you can justify it?
Well, I'll start, I guess. That's a huge gamble. A leap of blind faith because it's a big nut and very expensive equipment, particularly for the 900 series. So we just didn't know, and we didn't know how the material would react with our process, our chemicals. So it was logistic. It was out of necessity. We had no tradespeople left. We had to do it, and the ROI analysis has been remarkably successful because of the volume of business.
Would you have done it sooner if the ROI was?
Actually, would not have gone it sooner because we actually tried the Z-Core process maybe 5-6 years ago. It was not that great. We also tried some other processes and we had failure at SLA and just not success. So the FDM technology with Stratus has really flourished in the last 6 years, I guess.
In Bowles, we started agitating for an RP machine 4 years before I got my first machine. And every year in budget cycle, we would come up with, hey, this is how much the machine costs. This is what we think we can do for it. And my president would look at me and goes, how much money do I spend at a service bureau? And I tell him the number. And he goes, well, it's going to tell me it's going to take you 10 years to pay off that machine. You can't do it. And every year the prices come down a little bit more and a little bit more. But what really helped us is that the development cycle also shrunk during that time. So 4 years before my first machine, I might have had a 2.5-year development cycle for a consumer product. By the time I got my first machine, we were down to an 8-month development cycle in the spa industry. And I couldn't afford the time it took to go to a service bureau, get a part credit, and bring it back. That was 3 to 4 days. I mean, I literally needed stuff overnight to make my customers happy. And then it's that time that becomes the cost. And how do you time out your cost? How do you cost out your time? And that's for us is what it did. Is that was the stepping stone for us. Is like, okay, we know we can't pay it back as fast. We know it's not going to be as cheap as going out of house, but we're going to save all this time. And then here's the miracle that happened. Once we had it in-house, everybody in the company was like, well, I would not pay to have that part done out of house, but I can do it in-house now because it costs next to nothing resin-wise or material-wise. Like I said, we've run 10,000 parts off that one machine, and we may have done 300 parts a year before that. I mean, it's amazing all the opportunities you have once you do it. So it is an ROI, but there's a whole bunch of stuff that you can't communicate to your management, time and opportunity that you get once it's back. And like I said, my second machine, no brainer. I went to my management, I said, here's the capacity I'm running at, here's what I want to do, and he handed me a check.
So before you had to look reasonable ROI.
Right, right. And like I said, there's that time factor, boom, I snap right over.
Can I second that? I'm sorry. I was going to ask, how many people in the room I think are close to the ROI that's not there? How many people who are considering it think they're close to an ROI and they're not quite there yet? You have to educate the accountants. The problem is that time to market or time to development is worth a fortune.
But how do you cost that?
That's the problem. I mean, we went to a users group and they had a guy from Honeywell, had a jet engine part that didn't work after 9 months waiting for the investment casting. He had 40 engineers on the development of the engine. And he went to their rapid prototyping group that has metal machines. And they said, can you make it? And in 2 weeks, they made him 3 different ones that they could test. Now, you're not going to fly these things, but you could test them. And it solved the problem. He said, right there, that was worth $1 million.
The other thing that I think is really important about bringing the equipment in-house is the knowledge that you develop in-house. So I think everyone today talked about the creativity and limited only by the imagination, and that's absolutely essential on this technology. And when you bring the equipment in-house, then you're not only enabling one project lead or one engineer, you're actually enabling your whole company. And Jim Schiffer, who was slated to be here today, he's another case in point from Dixon Valve. They bought their first machine. They were going to serve, I think, two sectors in Dixon Valve, and they ended up serving 6, and it paid for itself in 18 months. But I absolutely, Bill, you're correct that we need some good information out there in case studies about the technology. Okay, hold on. Front row, and then striped shirt, and then one of the PCS guys. You guys choose.
Mine's really easy and not very exciting. We're thinking of possibly getting involved with doing some jewelry pieces. So, you mentioned about the integrity of the material and breaking down and all the et cetera, et cetera. You mentioned something about impregnating it with I noticed a piece back there that was bronze plated. And we talked to our plater who does metal. You can't plate over glass or any polymer. Who's doing that content?
I'll grab that real quick. So here in Maryland, we have a really wonderful company called Repliform, and they're in Glen Burnie, and they specialize in metal plating over 3D printed parts. So, right, and so that's why we're here. That's why we're all here to connect those dots. So talk to me. So I know I'm watching the time and I'm seeing the hands, so I'm not cutting you off.
No,
but
that's an easy question.
Yep. Okay. All right, strip shirt. Say your name. So I don't have to
My name is Phil. Is this thing on?
It is.
I had a question for Mr. Chow. I noticed on your slides there that you were doing EDM. And I was wondering, why are you using such an expensive process to make a mold? Why not use laser sintering? Is it because it's cost prohibitive, or you just find that EM is a quicker way of doing it?
The finish that we need for the mold, the detail, printing is not quite there yet. Maybe another 2 more years. Because to release the part, you need some nice surface and some good, yeah.
So you're looking at like what, a 30-second micro finish or 63rd?
It really depends on the paper that you can afford to have on the part.
Okay.
A lot of times what happens is that we get a 3D model from our clients that this is what they want.
Yeah.
In industrial design has already spec'd that out. Okay, that is it. I mean, sometimes you can go back to them and say, hey, can I have another degree here? So they won't be tearing it out.
Okay.
So that's one of the reasons. You have to make sure that when you're running in production, it's 100% coming out. You don't want it to get hung up in the mold. But yeah, no, that is also, yeah. No, sintering is definitely, I mean, we are using it.
Well, one of the reasons why I really asked that is because I've noticed that in the automotive industry, especially for Formula One, they're making heat exchangers for these cars out of the FDM laser sintering process.
Right.
So you know, I mean, and if you look at that, if you do a cross section of that heat exchanger, there's no way in heck you're going to build it from machining it.
Yeah.
So
we actually combine the two technologies. That one plus the
okay.
Hi there. Yeah, I'm Rob Himberger from PCS Engineering. One thing that perhaps I wanted to get your comments on is I know from my perspective doing industrial design, one big advantage of having the machine in-house is that it's not even a matter of your existing processes becoming faster, but that you can have more iterations and options at hand. So instead of saying, oh, I have one problem to solve and I have one solution, I say, well, I could kind of iterate that out in my head and then end up testing a lot. Or I say, oh, I throw 4 designs out there and I can do them very quickly. And I know it was mentioned earlier about resin consumption on the machines, and I feel like that's something that when you really get these machines in-house, you begin to understand that you are able to change your design processes that are on answering specific questions in your application and not in your head, not in your CAD program and so forth. And I'm wondering, I mean, I've seen some examples of that, but if there's anything more specific in that regard that you could perhaps tell people about maybe some project you've done.
I'd like to just share with you, I think everyone on the panel here has something in common, and that is 3D printing is not our core business. And you should listen to this, because 3D printing is very expensive, and you just don't want to go out and buy a printer and say, I'm going to be in the 3D printing, and I'm going to start ringing doorbells and going after it. We all have our own niche in what we do, and we've used 3D printing to grow our own core business, and that comes in with rate of return. So your question, Jeff, for example, could be, how much has your business grown with products and injection molding with 3D printing, not just paying for the printer, but just your entire company. So from that standpoint, we're all facilitating our own products. We all use our own machines for our own benefit, and if we have extra time, I guess we could job it out, which we do as well. But that's a key part of, I think, of our commonality up here, is that we're growing something using this technology.
Last question. Go ahead.
I was just going to say, we do a lot of DOE type work. We recently designed a small automotive centrifugal pump. And we weren't exactly sure what the vane shape needed to be relative to the volume shape. And we had a general idea of where we wanted to be, but we'd go 3 or 4 steps this way and 3 or 4 steps that way. And by printing those and testing them and understanding what the relationship between those different shapes and clearances were, that money we spent in resin more than paid off in not making the wrong hard tool at the end. So you can definitely do that. We do DOE work all the time. All the time. Spring legs on the little nozzles that clip in the hood, you're never sure exactly where you want those to end.
we'll print out 5 or 6 different versions, try them out in the stainless steel fit fixture before we do it. But that's returning an investment on not spending it on the tooling later, or incorrectly spending it on the tooling later. So you can definitely do it. And it's definitely worth the cost. I mean, $6, $7 a cubic inch for the materials we use on our machine is well worth not having to rebuild a $30,000 unit.
All right, I'm sorry, 2 last questions. The gentleman from North Grumman, the McGallias, and then I just want to kind of give you an alert. We're going to take a tour of the Innovation Prototyping Lab that's here at MCE. For anyone who wants to go on that, we'll try to keep a little bit on track. We're right at 9:30. So after these last 2 questions, I'll take some folks out here. Sydney will also guide people. So I know some of you are going to grab each other really quickly, but they want to catch up. So Sydney will show you the way, as well as Greg Gold, who is also one of our invaluable assets in the lab. All right, Northrop Grumman.
With so many different 3D printers out there, how did you guys choose which one fit your needs best? And how long do you guys expect that to last before having to upgrade to the next 3D printer?
Well, we were doing a Connect, actually a Connect that was shown earlier for oxygen sensor. This was way back, probably about 15 years ago. What we did is that we looked at 3 processes, laser sintering, FDM, and stereolithography. Basically, it confirms is that if you can find little details, definitely go with the stereolithography, but now with newer machines, I think you can also get the detail. FDM is probably not so suitable for really fine detail. They were all falling apart, and some features did not even show up on the model. Laser sintering wasn't bad, but still not good enough. But again, like I said, there's newer equipment out there right now that I think you need to check it out, because a lot of what we have used in the past is now kind of getting obsolete because of the new technology, new material. More to come.
Do you think PolyJet is going to take over the FDM?
I don't know.
I'm Bob from PCS Engineering. I just want to let everybody know, if you don't realize it, patents have expired on FDM. And the word on the street is there's going to be 200 different companies selling FDM printers at ridiculously low prices. So, if anyone here is curious about what that technology is like and what it costs, start looking now, but in a few months, it's going to be even cheaper. My thought is, start with an FDM machine, okay? And show your management how you're using it. And they'll see the benefits.
All right, I'm gonna, I see that I stepped down the room and things went awry.
Bob, you owe me a question.
I made PCS choose, and then when I turned my back, they took both slots. I'm gonna give Rennie Eaton a chance to respond because she had her hand up and she has a variety of equipment in her company. And then we are going to Mike Galeazzo for the last question.
Yeah, just quickly, I'm Rennie Eaton, I'm with Rapid Make. I have a fact sheet that I brought with me that talks about the respective strengths and weaknesses of each of the technologies in case you're interested. So that's available.
All right. So before I turn the mic over to Mike, I know, it's always an accident when that happens. I want to introduce Eric Guzman. Eric Guzman is the lab manager for the Innovation Prototyping Lab here at Maryland. And so when I take the first group over for the tour, some of you are going to hang out, want to chat, but then you're going to want to catch up. Or if you have questions about 3D Maryland or you want to work with us, Eric's your guy. All right, Mike.
Okay, rather than a question, since Bob took it, I'm just going to say, John Danko, you said something very important. Your core business is more than just 3D, which is worth mentioning in terms of manufacturing, growth of manufacturing in Maryland. It really is all about cost, it's about customers, it's about quality. This technology clearly, as evidenced by this panel discussion, helps manufacturers in Maryland with that issue. There are other issues, And I'm not going to ask a question because we want to get out of here, but I just want to say I'm so impressed with what I heard here today, Jan. This was an excellent forum, and RMI was really happy to be a part of it. And to everybody up here, thank you so much.
There's more treats. Please use the time to network. There's a lot of great information. Thank you again, panelists. You're phenomenal. Anyone who wants to go on the tour? I'm your tour guide.
You can go down that hallway and then at the end make a left and follow.
This is a really great form to learn more about it and the actual applications of it. I just finished my sophomore year, so I still have plenty of time to learn more about it.
Yeah, we're definitely it's definitely coming of age, and we're definitely in flux here. I've done a lot of work with out-of-school programs in 3D printing also, and namely the Digital Harbor Foundation down in the city. And we have worked with cohorts of high school students over the last couple of years. And one group is graduating this year, they're seniors, and when they went to colleges, Greg, will you also put the video on?
Sure, yeah.
And then when you get a chance, the website and the survey on the front 2 monitors, it should be up from yesterday.
Okay.
She went to interview colleges, and she said, so, did you have 3D printing? Do you have a makerspace? And they're like, no, what is that? But so I think it's where we are. I think we're hitting these crucial points that are crucial, but I think we need to do it all the way along the spectrum. So for those of you who don't know, I built a comprehensive digital fabrication lab at Towson University, and we do offer 4-year degrees in that. Dave Hinton is here from Howard Community College, and they have 3D printing at Bay Community College, and we mentioned CCBC's Fab Lab today, and Micah has a digital fabrication lab. So there is some stuff going on at the educational level. More needs to happen, and more different kinds of things need to happen. But what industry watched me at Towson and said, what you're doing is great, but we need you out here for industry. So hopefully we have some educational stuff in line, and now we can hop out here and create some demand and really work together, because that's where we are. We have to work together. Okay, so this is the Innovation and Prototyping Lab here at 3D Maryland. It's really a knowledge resource center for the state. And so our mission, we're located in Howard County, we're funded by Howard County, but our scope really is statewide. Steve is from Carroll County, LAI. I've been up there several times. Mike Galeazzo and I talk all the time to all kinds of groups. So this is really, we are technology agnostic, both in terms of the printers and in terms of the software. We want to be a resource for people to learn more about the technologies, what they do, what they don't do, and you heard that today. So sometimes the resellers are not terribly happy that we're here because they want to sell you a machine, and we want to help you find the right solution for you. And so you're going to hear a lot today. You heard Stratasys and 3D Systems, Stratasys and 3D Systems. You heard, EnvisionTech. There's actually 7 different 3D printing technologies out there, but you heard just about a couple of the players today. And so we want to work with you to help you find the best solutions for what you need. And so oftentimes that starts with understanding and seeing the technology and process. And so where Greg is sitting, the first computer station there, we're calling our Genius Bar, and that will have really accessible technology on there that people who don't know anything about it can come and start to play around with some really simple low-end CAD software, and we'll have some just simple stuff there. As we work our way back through the lab, the 3D printers get more complex in nature. So this is a MakerBot. It's the Replicator 2, and it's the most popular consumer-grade printer on the market. Now, some people say, I thought you were for business and industry. Why are you showing me a desktop model? Because, and you might have heard this today, companies have to start to implement a digital workflow and a digital culture at some point. And this is a $2,500 3D printer that is really reliable, and it's plug and play. This is a terrific starting point. Ford put one of these on every engineer's desk and said, I want one. Okay? So this is not a toy, even though it's a desktop printer, this is not a toy or to be dismissed quite so easily. As we go back through the lab, and you're please welcome to walk back with me, this is a desktop SLA. The language and nomenclature is not very interesting and only cumbersome probably to you. This is a vat of resin. There's a laser in the bottom. The build platform is the square that we see at the top. When this starts to print, the build platform lowers all the way to the surface of the resin. The laser cures the resin and it moves up layer by layer. What's on there right now is a test piece. Looks like this. I forget how long this took to print, but there's 587 layers on this in this piece. Actually, this is a replica we're doing with one of our advisory board members. This is a steeple of a church that took 5 hours to print. The same piece on the MakerBot will probably take, not apples to apples, so don't get the impression that you actually can print this on the MakerBot. You can, but it would probably take maybe 45 minutes on the MakerBot. So there's a lot of apples and oranges and grapefruits and pears and all persimmons in this fruit basket to kind of sort out. What is important about the SLA technology is that this is the first 3D printing technology to be commercialized from the University of Texas in the mid-1980s. It has the highest resolution, but it will never be an end-use part. It will always be an intermediary, so it will be a step on the way to another process. What I hope was valuable to you guys about the panel today is John Danko actually made a comment. When we started with SLA. There's no way that would work in the foundry industry, okay? And so those are really long discussions, but what we want to do at 3D Maryland is bring the ecosystem together, put you in front of these different players, so then you can follow up with them and kind of get firsthand information about what works, what doesn't. This is the Projet 660, and we'll open this up for you. This is a little funny today. This is what the Stanley Black & Decker has 2 of these, and the drills that were on the table and floating around today were printed on the Projet 660. This is the plaster printer, so this is a bed of plaster. So we have, I didn't say this on the MakerBot, but that's actually PLA. It can be PLA or ABS plastic. PLA is a green compostable material, so that's nice because we are cranking out a lot of stuff with these 3D printers, and a lot of it is plastic. So plastic or PLA, resin, plaster. And this is a bed of loose plaster, and you're welcome to touch it if you'd like to. You can get a feel for that. In the industry, we call this cheap-tastic because the material is so inexpensive. It works very, very quickly, and you really get, very quickly, you get a prototype out. And hopefully Stanley Black & Decker was a really great case in point to say, look, we print this out, we put it in people's hands, and we observe, we do our user studies off of that print. And there's a lot of tips and tricks in the trade. And so I didn't know about the wood hardener, that was new to me, but what we oftentimes use is a polyurethane as an infiltrant to harden this plaster. We did awards for the Department of Business and Economic Development last year for the Invest Maryland Challenge Awards. And when they came to pick them up, like we took them through the whole lab at Towson, we told them what we're doing, when they were involved with the whole process. When they picked them up, they're like, no, what are these made out of? And that's what's really interesting about this technology is like, wait a second. You've seen the lab, you've seen 1 million parts come out, you've seen them running, we told you what we're using, we have an agreement with you. But when you look at the final product, you don't get the impression that it's infiltrated plaster. And they said it looked like marble. So there's a lot that goes into, and you can get out of 3D printing. So we purchased this machine for this lab because it's one of the biggest build platforms on the market. We can't compete with John Danko. John Danko's machines are $500,000 machines, just so you know. That 36 by 36 by 24 is a $500,000 machine. John Danko has capacity on his machines. If you want to print polycarbonate with the FDM process, call John Danko. He will print for you, I'm sure. This is an 18 by 10 by 18 build platform, which is quite large. A great application here is for both engineering models, but also architectural engineering and construction models. So we're really trying to look at our ecosystem and fill the needs and fill the gaps in there. The other thing about this printer is it's full color. So we had Yoda around here. This is one of the test pieces that they pulled off of it. So again, whether it's an engineering model and you are marking, these parts belong to this division, these parts are mechanical, these parts are industrial, these parts are electrical, and it's a visualization that way, or whether you're an entrepreneur and you want to take photographs of people and create customized fill in the blank, okay? So full color printer, think about, and your homework is to think about how you might use it, what the applications might be. And then in the back, in the back we have 2 FDM machines. This is the Dimension Elite. This is the top of the line professional grade 3D printer from Stratasys. So Stratasys has 3 levels. Actually, Stratasys bought MakerBot a year or so ago. So now MakerBot is Stratasys entry level. Before Stratasys bought MakerBot, this was our entry level, the Mojo. So Stratasys, as you probably understood from today, is a pretty serious technology. They're not goofing around. So the technology is not always quite there yet, but Stratasys has always been a very serious player in this space. They want their technology to be as good as it can be whenever they put anything out. And so this was actually their desktop printer, but this cost $10,000. That's not exactly an entry-level point for someone getting into this technology. And so they have 3 levels, the MakerBot entry level. The Dimension is the professional grade. This is the highest resolution of the professional grade. And then the Fortis line is after that, and that's where you see John Danko's Fortis 900 is the top of the line of the industrial. And then while you're in here, you're welcome to tool around while we catch up with other people. We have some videos playing in the front, and these are some of the Maryland companies that use the technologies. UAV Solutions is a great case study. They could not be here today. Bill Davidson is on our advisory board as well. He's the CEO of UAV Solutions here in Jessup, Maryland. Started in 2007 with 11 employees. Today they have over 55 employees. They have 6 3D printers that run 24/7, and they actually run, I believe, the 250s. So the Fortis 250, so the entry-level industrial grade. And their biggest problem right now, as I understand it through the grapevine, is how do we scale? We have all this demand, we have so much work, how do we continue to scale? And that's a problem that we want Maryland to have. So then we have about 8 computer workstations here. They're high-end industrial grade workstations. We have state-of-the-art software on there. We have SolidWorks. That is industry standard software. We also want to really support the ecosystem as we move forward. So you heard that there's a lot of barriers with the technology, and some of that is materials, some of that is cost, and that is materials and software actually are 2 of the factors that really hold the industry back. Software is lagging. The functionality of the software is lagging. It's not quite where it could be or where it needs to be. So we have a full premium suite of SolidWorks. That's a that's a tremendous cost. And so what we're going to do is we are still working out our business model, but we will make these workstations available. In addition to hosting a user group and bringing in SolidWorks experts, we will make these workstations available to people so that they can start their companies, they can integrate the digital workflow into their business model, however we can help. We also have Modo on here. Modo is software that I've been really impressed by. It's newish software. It's also a deep package, but I do believe it is pushing the boundary of the software. It's probably none of the software that we have today is where it needs to be, but I really think that Modo is another step forward. So that's when we talk about being technology agnostic in terms of the hardware and the software. That's what I mean. We're not going to be a SolidWorks lab. We are so proud and so happy to have a premium suite of SolidWorks here for Maryland to utilize, but we also have Modo, and we won't pick and choose. We also will have some freemium software on here as well.
Is Modo surface modeling, or is it finishing, or?
It's actually a combined surface and solid. Yeah, right? And then you heard Tyler from Stanley Black & Decker talking about KeyShot, which is fantastic. Rendering software. Modo has an incredible rendering engine as well. So that, like I said, that's kind of like that's a step closer to where where the software needs to go, and so we're happy to have that for you too. So where we are today is what I've been able to glean as the data points and the signal points in the time that Mike and I have been out here kind of coalescing the ecosystem. Please take the survey that's on the website. So the website is 3dmaryland.org. Right on the homepage, there's about a third of the way down, it says take our survey. Literally, it's 8 questions. It'll take you 2 minutes. But what we want to make sure is that we are filling the gaps that need to be filled. So let us know how we're doing. Okay, so I'll be quiet. Other questions? Oh, the last thing I was going to say is we have a showcase here. Most of it's empty right now because we moved it over to the other room for today. But we want to continue to grow a showcase of Maryland companies using the technology. And so you see some logos up there. A lot of those samples will be back here. We're continually asking companies to contribute models and examples of how they use the technology. So if you are a company and you're not a part of our showcase yet, please let me know. If you know a company that you think should be in our showcase, please tell them that we want them, because we do. But anyway, we can work together on that. Okay, questions?
Jan, is any of this equipment manufactured in Maryland?
It is not. It is not. And I do want to do a plug. There is a new desktop printer called the Micro 3D, and it is designed by University of Maryland grads. The parts are being manufactured in China, but they are trying to assemble those in Maryland. And one of my other missions outside of this mission, is to get a 3D printer in every school and maybe in every library in Maryland. And I think that would be a terrific story for Maryland if it was Micro 3D. If it was designed here, the IP came from here, and then our manufacturing friends are working on how do we get it manufactured here. So there's a team on that for sure. But what a great story. So already when I'm doing congressional testimonies or when I'm at the White House for Office of Science and Technology policy meetings, already people are saying, wow, no one else is doing this. You guys are really together. You're the blueprint. Let's not rest. To me, that's encouraging, but I say, let's do what Jeff is suggesting.
What was the June SolidWorks date again?
The 19th of June. They're Thursday evenings, 22nd of May and the 19th of June. Other questions?
I joined this late, but what exactly is the mission of this lab?
To help business, industry, and entrepreneurs engage and implement 3D printing technologies.
So can we come here and test out our solutions?
Yeah.
Is there a charge there, or is it?
Yeah, we're fee for service.
Okay.
And we're still working on the model. So, and I feel bad saying that, but here's honestly what's been happening is everyone around this mission goes, wow, we had no idea this was going to be this popular or this big, right? And so things like what happened yesterday happened where Fox 45 says, hi, we want to broadcast live for 4 hours from your lab. You don't say no to that. But there's a lot of that, and so so right now we're still, be patient with this, we're still kind of hobbling along. But what we really love more than anything are early wins. And so when I set up my lab at Towson, I went for the shiniest low-hanging fruit, and I grabbed as much of that as I could. And so when I started this lab, I went back to some of the folks who were really championing me there. And I said, okay, what's your advice for this lab? And they said, just do what you did at Towson. Just do what you did at the Object Lab, because you just got early wins out of the gate. So we are really working with entrepreneurs and businesses. So if there's something right in front of us that we can help you with, we prototype for a lot of entrepreneurs. Unfortunately, entrepreneurs aren't great at filing patents or getting patents as they're developing their products. So we can't talk about a lot of them. But we want those early wins. So just either myself or Eric, we can turn stuff around. We turned something around last week. It came to us at 4 o'clock on Thursday, and we had it out by Friday afternoon. And we want to do that because that's not about us. The reason that we were motivated to do that is because those engineers at that company said, if we can do this, we can prove to our management the value of this. And we said, absolutely. So that's what we're about. We need to cover our cost. We need to make sure that we're sustainable, so we have the resource for Maryland, but we're not a for-profit. So we need to sustain ourselves, but what we're trying to do is really sustain Maryland and help Maryland be more competitive. Other questions?
You were talking about different opportunities for students or undergrad. Just like personally, I'm really
See me after. This poor girl, she's emailed me like 4 times. Now what happens when I go to events and go, oh, it's so good to see you. I'm really sorry to email me back. I'm really sorry to see you. Email me back. I do. Raise your hand if I have been responsive to you. Thank you. And it's nothing personal. It's just the luck of the draw.
Yeah, it's cool.
Other questions about the lab or 3D Maryland? Really? No other questions?
I do have a question.
Answer everything.
One of the guys
I know I talk a lot.
talking about the bridges, and I don't see it particularly.
It is on these very clearly. And so these are actually, these are off of the MakerBot. Not all the prints are terrific. This one has a little bit of separation and cracking. That should not deter you. So this is FDM. And Greg, do you want to hit go on that one? And we'll just print the stretchlet. I think it's probably up there from yesterday. So we print this bracelet, and you'll see the price room around the lab. They print in about 25 minutes. And what's happening here is the coil on the back of the machine is the PLA. It's of the filament. It gets pulled into a heated print head and deposited. We use deposition modeling. Is this technology? It's the same as the Dimension Elite in the corner. This is $2,500, and that's $50,000. So when you see a splitting off of the MakerBot, don't go, I'm not getting FDM, because that has splittage. Not necessarily, okay? And here we really print very straightforward. In the back, orientation, you can strengthen your prints in a million ways just by things like orientation, design, etc. So, but the layering is the same, is virtually the same. It's finer. But and this is the technology that John Danko uses, and he has the $500,000 machine. He still gets stair stepping on with the FDM process. There's still stair stepping, and that's what he was talking about. And for his application, the sand catches in that stair stepping, and that's why he has to. But remember, so on the machine right behind Gary, the SLA, there will be 0 stair stepping on that. But that does not have an application to John Danko's foundry. Okay.
But that little thing could print something this big and this thin, couldn't it?
Absolutely, yeah,
And how
absolutely.
much is that machine?
3,300.
3,300?
And the other thing I want to say to you guys is so use us as your knowledge experts, right? And so what some of the resellers will not like about me is I'm going to tell you the truth. And they're not, and I'm not saying that they're not truthful, but I'm gonna say to you, I'm gonna give you the history on the machines as I understand them. And so this is a desktop version of the first printing technology. The industrial versions do not have the problems that I've had with that. Okay, so there are some issues with that particular one, but it's $3,300, right? But again, like I want to make sure as you work with us and you get more information that you understand that, yeah, $3,300, but is it going to be a slam dunk for you? It's not. It may not be. Okay, so that's really important to us that we set people up successfully. Other questions? There's a quiz before you leave the room, so make sure you know everything.
So some of those things look really smooth and really just from a distance. Do you go back and sand them?
John Danko does, so many people do. There's a lot of post-processing methodology that you can do. And I'll grab an example of technology that we don't have in here. These two, you heard the term SLX today and nylon. These are two nylon prints. Nylon is a very sturdy material. When that comes out of the machine, it's tumble finished, much like jewelry would be tumble finished. And there again, there's a lot of different grits that you can use. So post-processing almost becomes proprietary. So how Under Armour post-processes versus John Danko, they might tell you, and that there again, that's why the professional user group is here to build a trusted community where people can share their best tips so that everyone benefits and everyone learns from that. But there's a lot of post-processing, and just like I just said a few minutes ago, I didn't know Tylen infiltrated with wood hardener, whatever he said.
That's what's really fascinating.
Right, so that's the thing, like I didn't know that, but I sure made a note of it, right? But I told you guys today, hey, we infiltrate with polyurethane, that's a great tip, right? And so 3D Maryland is about building the ecosystem and building that knowledge base. And just like you build a knowledge base as a company when you bring the technology in-house and you start to think differently, and that's really the point. So we're trying to fill the gap here and trying to give people reliable information and share the information that we have. Other questions?
How easily does the, say, SolidWorks model and the format you bring it in, does it integrate to the printer?
So that's a really great question. The question is how easily does the SolidWorks model integrate to the 3D printing process when you bring it in? That's the benefit of using industry standard software beautifully. So if you can design with that software, and it's very logical, I really like SolidWorks. If you can design with that software, you have less problems bringing it, but you have to know how to build the geometry. So, and this is one of the kind of back and forth that happens really quickly, right? So I just said, oh, it's really easy. Then I go, oh, wait a second. I know how to build geometry with software, right? And so there is a skill and an art to that too, how you build your geometry to send it to a printer, but then also which printer are you sending it to? And so the advantage of labs like this is that there's a knowledge base here. At Towson we have eight different printers now, and 4 different printing technologies. So we train the students to design, like we go give them a project on the Eaton, we give them a project on the Z-Core, and so that they learn to design for those different technologies. So it's when you use good software, it's easy, but you have to know how to design with that software. Dave, do you want to jump in on that question? That's you all. He always leaves me out here by himself. Howard Community College. He's being quiet, but he knows a lot. You're welcome to jump in. There's a lot of free software out there. I'm a big fan of the free software. This is another whole discussion that we can have at some point. Autodesk was a leader in software, it still is, and maybe 2 years ago they came out with free software, the 123D suite, 123D Design, 123D Patch, 123D Game. And you can walk into with 123D, you can put it on your phone, walk into the Metropolitan Museum of Art, Michelangelo, stitch it together, send it to a 3D printer, and you, consumer, has your very own 3D print, right? So there's some really easy free software out there. Within 6 months, I think I have over 1 million downloads of that software because it's so accessible to people. People are so curious about how to get in and how to work with it. Other questions?
Maybe by default, includes a text pattern inside.
Not
by default. You control it.
Use that what percent still is there small hints or you know in the programs that have different geometries that maybe like the geometry or
So the software with each machine is a little bit different. So you have different capabilities and different efficiencies with each machine as one answer. You can also probably design your own. There's a lot of information out there. There's a lot of ways to go. But what he's asking is, if you there's a presentation that I do that's online called Impacting the Business Model. And one of the advantages of this technology is that it's lean. So in the classroom printer, it recycles any material that it doesn't use. We don't have to build a solid object here. We also don't have to start with the solid billet and pause most of it away. We can determine what goes inside that. We really are here to grow the ecosystem. That is our metric. How many people do we touch? How many people do we help? The more people we can help, the more we can talk about our effectiveness. So please give us feedback. Let us know what we're doing right, what we're doing wrong. All right? You're welcome to hang out.
Thank you.
What is this going to do,
No. I do, of course. They are
It's not going to break, but.
So I